Hi data scientists, I'm Jessica, and today we're going to be learning about group by. So we're going to write Python code to calculate the major that admitted the most students and leave a single row of that major as the only row in the data frame DF applicants. So your solution must include only a single row for the major that admitted the most students, and that row must contain a major variable column. You can create extra columns if needed, only major will be graded. So we're given a data frame DF. And DF is essentially loaded with a bunch of admission records from UC Berkeley's graduate program in the fall of 1973. So each row of our data frame is a person that applied to this graduate program, and we're given the year that they applied, the major they applied to, A, B, C, D, E, F, and other, their gender, as well as their admission. So whether or not they got accepted or rejected. And we want to find which major, A, B, C, D, E, F, or other, admitted the most students. So there are a couple steps that go into solving this problem, and we're going to break them down first. So we want to find the major that admitted the most students. And another way of saying this is which major accepted the most students. And where do we figure out whether students were accepted or not? In the admission column. So since we want to find the major that accepted the most students, we don't really care about the people that got rejected. So the first thing that we're going to want to do is we're going to want to filter our data frame into having only the students that got accepted. And this is found in the admissions column. Okay, so now we have a data frame of all the students that were accepted or admitted, but we want to find the major that admitted the most students. So this means that we're going to have to group by major. So if you guys remember the syntax for group by, we always group by a column. So in this case, we're grouping by major so that we can find the major that admitted the most students. So after we group by, we always want to make sure that we're aggregating by something. So we have a data frame that accepted the most students. And now we've grouped the accepted students by major. So in order to figure out how many people were accepted per major, we want to count how many people that from our accepted data frame are there per major. So we're going to aggregate by count. Okay, so now we have the count of all the people that were accepted into UC Berkeley's graduate program by major. We want to find the major that admitted the most students. So we want the largest one. So we're going to find the largest out of all the people that were accepted into all the majors. So let's take a look at how our code is going to look. So the first thing that we're going to do, first step, is filter into only accepted. So we're going to use the admission column, and we're going to figure out who are the people that were only accepted. So we want the students where their admission is equal to accepted. And we're going to store that into a data frame called DF admitted. So our output is going to look something like this. We have all of our columns, as well as you can see, everyone's admission is only accepted. So now that we have all the accepted students stored into our data frame DF admitted, we're going to group by major and aggregate by count. So if that didn't really make a lot of sense as to why exactly we're doing that, it might make more sense if we actually take a look at what exactly is returned. So as you can see here, we have our 7 majors, as well as the count of how many rows essentially are there per major out of all the people that were accepted. So we have our data frame, DF admitted. And let's take a little sample in order to explain exactly what is going on. So we have year, major, gender, and admission. Okay, year, major, gender, as well as admission. Okay, so the year for everyone is going to be 1973 because this was the graduate program in the fall of 1973. The major is just going to be the majors they applied to. They're just random. Let's say there's another A, there's a B, there's a C, and there's an other. Okay, The gender as well, let's give them all arbitrary genders, male, female, female, male, male. And the admission is going to be accepted for everyone because we already filtered out only the accepted people into our data frame DF admitted. Okay, so what group by is going to do is first, essentially, it's going to organize all of our rows into whatever we're grouping by. So let's say we're grouping by major. Then it's going to organize. So we have 3 A's here, here, and here. We have a B here. We have 2 C's here and here, as well as a D and an other. Here's 1973 for all of them. Gender doesn't really matter. And the admission is that they're all accepted, right? Okay, so now that it's organized into all of the majors like this, what aggregate by count, so group by major groups it by major like this. What aggregate count essentially does is it just counts how many rows are in each major. So aggregate count, so here if it's 3, 1, 2, 1, and then what it's going to do is it's essentially just going to fill all of the other columns with how the row number. So if we have major, A, B, C, D, and other, we're going to just ignore E and F for now for this example. Then for year, gender, and admission, it's just going to fill out how many rows that it counted per major. So A, we counted 3. It's just going to fill 3 everywhere. B, we counted 1. It's going to fill 1 everywhere. C was 2. I don't know why I wrote D. C is 2 everywhere. D is 1. And other is also 1. So this is how this example looked like. So that's exactly what is happening here. It's grouping by all the majors, and then it's finding the number of rows that are that each major has, and then it's putting the total in each of these columns. So essentially what this means is that in our DF admitted, there were 914 rows with the major A. In our DF admitted, there were 370 rows with the major B, etc. And since DF admitted only had the people that were accepted into those majors, that means that 914 people got accepted into major A. So hopefully that makes a little bit more sense into why we're grouping by major and why we're aggregating by count. And as always, it's very important to remember to reset your index. That just resets this index here, and it's just a little thing to stop pandas from messing up things later. So just as a little curiosity exercise, let's see what would happen if we aggregated by sum instead. So sum essentially just adds up all the values in our columns. So if we have 973 here, it would just add 973 all down the column. So you could only sum up numerical values. So it's actually going to ignore all the columns that don't have numerical values. So it's going to ignore major, it's going to ignore gender, it's only going to ignore admission. And this is what our output's going to be. It's just going to be grouped by major, and it's just going to sum up the year, which is pretty useless, but it was a little curiosity exercise. So now, just to recap, we have all of our majors, and we have the number of people that were accepted into each major, right? AKA the number of rows in our DF admitted, which has only accepted people. So now we want to find the largest one. So just by looking at it, we can see that other is our winner with 364 people accepted. But we still do need to write code for that. So if we take a look at our pandas cheat sheet, we can see that we have a command called dfnlargest. And then if you input how many largest you want and which column you're looking at when you want n largest, it'll give you the n largest. So in this question, this question is asking for only one largest, the largest. So our n is going to equal 1. And then if you actually look at the data frame, since we're counting the number of rows with the major A, all of our columns are actually going to have the same values. But for intuition purposes, since we're trying to figure out which major accepted the most people and that acceptance is stored in our admission column, I'm going to make value equal admission. But you can honestly make it any column you want. So just to recap, we want to find the n, or in this case 1, largest value from the admission column, which would be this one right here, 3,164. So the code for that would look like this. DF applicants, because DF applicants is, we stored this data frame into DF applicants, and now we want to find the largest of this data frame. So that's why we're using DF applicants. So we want to find the largest. N is 1, value is admission. And that would result in this, the largest, the major that accepted the most number of students, which is 3,164.